Hello, and welcome to the presentation of the Red Village. We are Team Selene. My name is Aaron Sittedeth, and I will be talking to you today a bit over the background of our project and our overall base. Next, we'll have Christian, who's going to talk about the specifications of our module and the transportation methods. Then we'll have Christopher, who's going to talk about the fish aspect of our aquaponics module, while Cassandra talks about the vegetation aspect. Then we'll have Edgar to conclude our presentation. Here is a quick layout of the subjects that will be covered over this presentation. NASA wants Mars to be the second safest planet in the solar system for human inhabitants. The reason for this is because water was found on the surface of Mars. And if there's water, then humans can live there. But there is no food source. Our solution for this is to create a food production system for the initial Mars crew by implementing an aquaponics module. An aquaponics module utilizes plants and fish to create fresh food, where the plants clean the water for the fish, and the fish create ammonia that is converted to nitrites by the bacteria used by the plants. To the left, we have a drawing of our interior layout. To the right, we have our overall base design, where the snowflake design makes other modules easily accessible, and the geodesic dome shape creates a structure that can withstand high load capacities. And next, I'll pass it off to Christian.
For our module, we will be using something similar to a cargo container. It is going to slide out from the sides, much like an RV, creating more space inside the module. This module is already in use by the military for kitchen modules. We will be able to take this and implement it for our own use for our Mars application. Next slide. This is a cutaway view of our module interior layout. Blue represents our fish tanks, green our grow beds and microgreen trays, and yellow for our lights. For each grow bed, we are going to have 6 plants per grow bed. Microgreens grow in a carpet-like fashion, much like grass. Our tanks are going to be 265 gallons each, and we will have 4 of those, holding up to 84 fish per tank. And grow lights throughout our module are up to 45 lights for the module entirely. For transportation, we plan on using SpaceX's Starship to transport the module prior to crew arrival. With a payload of more than 100 tons, Starship outclasses NASA's SLS at a projected launch cost of around $2 million. Seeds for the new world will be shipped in similar condition to those stored at the World Seed Bank. Cool, dry, and vacuum sealed. Cryopreserved eggs will also be sent with the crew for monthly thawing and deployment. Using cryopreserved eggs allows us to take a high capacity of eggs, meaning more fish. Also, this allows for low tending needs from the astronauts to care for them. Now, I would like to hand it off to Christopher.
In order to maintain production and sustainability, we need a fish less prone to ick, able to be bred, and finally harvested within their first year. The darker fish you see in this image are 12-week-old tilapia. Out of a selection of FDA and EPA-approved fish for consumption, tilapia proved the best choice for the Mars mission based on their ability to be placed on an herbivorous diet, breedable, and harvestable within their first 9 months. These fish require water at a ratio of 1 pound of fish to 3 gallons of water. Studies of their natural habitat show that these shallow water dwellers are survivors in poor water quality with low oxygen and a wide range of temperature. Initial stores of fish feed will need to be sent until algae and duckweed reach production levels. And now I would like to pass it off to Ms. Cassandra.
Okay, let's take a look at the vegetation side of things. I'm sure you're familiar with vegetables, but I'd like to discuss microgreens. Microgreens are vegetables too, however, they come with many advantages. They grow very quickly, approximately 14 days. They require little maintenance. They're very high in nutrients, about 40% more than their mature counterparts. But more importantly, they work great with my aquaponics. The vegetables that will be chosen will be packed with vitamins that will promote healthy bones and healthy tissue, which are major concerns for astronauts. Our aquaponic system will require a filtration system. This biological system uses media pads and cartridge filters. Very little maintenance is required with the use of replacement pads. The pads have a bacteria that breaks down ammonia and nitrates within the water. And depending on how the pads are aligned, the design can help with extra filtration. This system requires no energy consumption. Rating filters for higher gallon capacity leads to less time addressing waste in the system. And now I would like to pass it to Edgar.
Okay, so one of the most important aspects that we need to consider in our module would be that of power consumption. This will tell us whether our module is actually feasible or not for the initial Mars base. Now, as you can see, we have grow lights for the grow beds. Then we have water pumps, aerators, and water heaters for the water tanks. What this allows us to do is make sure that the vegetation and the aquaculture will thrive in the environment of Mars. Now, you can see different units or different totals of how much the wattage would be inside the module. And when you take up the sum of everything, you get 8,500 watts, considering that everything is on at the same time. So this is considered peak demand. Now, this is great because it's underneath a 10 kilowatt nuclear reactor that would be provided to us from TSGC. It could probably be decreased, but that's something we will consider in the future. Now, to wrap up this presentation, I would like to consider that using only 8.5 kilowatts of energy and assuming that the daily calorie consumption of an astronaut is 2,700 calories, we would be able to provide 190 meals to the astronauts within a 1 year's time span. This is great because not only does it provide food for the astronauts, it provides it, fresh food. It won't be something that's packaged beforehand. This improves quality of life as well. And then this is also a psychological benefit. As you can see, vegetation and aquaculture alike thrive in the Mars environment, which means our astronauts will be able to thrive in the Mars environment as well. Now, in the next few slides, you will see references that we use either for information or the media we used. Thank you for watching our presentation. I hope you enjoyed it.